Hello all. This is a bearings question from the Physics and Maths Tutor, paper 3 predicted paper for 2026. A ship leaves point A and sails 18 kilometres on a bearing of 35 degrees to reach point B. The ship then changes direction and sails 14 kilometres on a bearing of 120 degrees to reach point C. Calculate the distance from point A to point C. Give your answer to three significant figures. That's part A. And then part B says find the bearing of point C from point A. We're going to do both of these. That's 5 marks total. So, with bearings, you have to measure, if this is point A, you have to measure from due north, clockwise, the angle that you are travelling. So, if I'm going to point B, it's going to be up here somewhere. That means I'm travelling 35 degrees from due north, starting at point A, in the clockwise direction. When we write bearings, you have to write it as 3 digits like this. So 035. Now, from B, we're also from due north, travelling, I'm just going to delete that. We are travelling from due north, 120 degrees from due north clockwise down to point C. I can label point B on there. So that's 120 degrees there. So, from point A to point B, that was 18 kilometres. And from point B to point C, that was 14 kilometres. What we need to do, for part A at least, is calculate this distance here, directly from point A to point C. So let's do that. First thing you might notice, because all of these lines are pointing due north, just here, the two lines on the left and the right are parallel, which means that this angle here must be 35 degrees because it is alternate to the 35 degree bearing from A. Now, we can work out the remaining bit of this internal angle of the triangle by doing 180, subtract 120, that gets us 60 degrees. Because angles on a straight line make 180 degrees. Okay, so we have A to B, B to C, and we also have this internal angle between them. That means we can use the cosine rule to work out A to C. So let's do that. AC squared is going to be equal to our two sides. That's 18 squared, add 14 squared, subtract 2 times 18 times 14 times the cosine of my internal angle there. That's 60 add 35 or 95. Now, you would do this with a calculator. Remember, make sure your calculator for the GCSE exam is in degrees, not radians. There should be a little letter D at the top, not a little letter R. I had to re-record this video because I forgot to double check that my calculator was in degrees. If you run that through your calculator, you should get 563.9264943. Remember, we don't round until the very, very last step to make sure that any loss in accuracy does not follow through to the final answer and lose us that accuracy mark. So that means that AC is the square root of that, which again, you'll just put in your calculator, and that gets you 23.74713655. And then, because we want 3 significant figures, our first significant figure is 2, our second significant figure is 3, our third significant figure is 7, so we are rounding to that decimal place there. The digit below that in the place value is 4, that rounds down, so it will remain as 23.7 kilometres. And again, this is a nice question to check for realism. If I sail 18 kilometres in one direction, then slightly change direction and sail 14 kilometres, I'm not then going to have sailed hundreds of kilometres or 0.4 kilometres total if I did it in one trip, yeah? So 23 kilometres is a reasonable answer. Okay, next we need to find the bearing of point C from point A. Well, to do this, we're going to need this angle here, because the bearing of point C from point A is this angle, let's call it alpha, plus the 35 degrees to take us from due north to the triangle. So we need to work out alpha, and then once we have alpha, we can work out the bearing by adding on that extra 35 degrees. Now, you might notice I have a 95 degree angle here, and I've just worked out that AC here is 23.7 kilometres, and I want alpha, and I have the opposing side in the triangle as 14 kilometres. So because I have these two pairs of opposite sides and angles, I can use sine rule. So we're going to have sine of alpha over the opposite side, which is 14, is equal to sine of 95, remember 35 adds 60, sine of 95 over A to C, which is 23.7. So that means that sine of alpha is equal to 14 lots of sine 95 over 23.7. Again, that is just by multiplying by 14. And then to get alpha, we'll use our inverse sine, or arc sine if you're feeling fancy. 14 sine 95 over 23.7. So, run that through your calculator. So we want inverse sine of 14 sine 95, close bracket, over 23.7, close bracket. That gets us 36.04847022. Okay, finally, we have our angle. We need to add this to that initial 35 degree turn from due north. So we need to do this number, that's 36.048447 ... And we need to add on 35. Again, just do this with our calculator. That will get us 71.04847022. Now remember, when we write bearings, it needs to be 3 digits and a whole number. So, to the nearest degree, this is 71 degrees. So our bearing is 071 degrees. So that is 5 marks total for a bearings question where you use cosine rule in part A and sine rule following on from part A to work out the bearing in part B. I hope this was helpful. Let me know what other topics you'd like me to do.